All right, so I'm looking at the exponent review sheet. There's a lot of practice problems on here, so I'm not going to go through each and every one of them. Otherwise, this video would be like half an hour long. And so I'll do a couple, just sort of random problems. But if you have others that look hard, please just comment on the video or shoot me a message or just ask me in class, and I'm happy to make more. But nobody wants to sit through a 30 or 45-minute long video where I'm going through each and every one of these. We also got the answer key posted on there, but if you want to see me do it in detail, just ask. So the first page is just looking at exponent properties, and a lot of these are just sort of making sure you're using the right rule. On numbers 1 and 2, I just have to add the powers. So that just is 2 plus 4 makes 6. On numbers 3 and 4, I'm multiplying the power because it's a power to a power. So I know I've got x to the 9. But you got to make sure that the 3 also gets to the third power. And so I would make sure to go 3 to the third is 27. And just remember, it's kind of like when we used to distribute, when we used to have problems that looked like this. 3 times 3 plus x, we would go 3 times 3, 3 times x. It's kind of the same idea, just with exponents. We do 3 to the third and x to the third to the third. And 3 to the third is 27, just because I went 3 times 3 is 9, times another 3 is 27. Problems 5 and 6, you're subtracting top minus bottom. And so that would be 5 minus 2 here. 5 minus 2 makes 3. Anything to the 0 power is 1. Anything to a negative power just goes on the bottom of the fraction. So those are kind of the more basic level. As we move down, there's a ton more. Get a little harder. I'm only going to do a couple of these, just sort of random ones. Let's try number 11. When I look at, I'm just looking for things that are the same. I see a 4 on top and a 4 on the bottom, so I can cross those off. And then I'm just counting up how many k's there are. There's one of the k's on top. On the bottom, I've got a 2k to the fourth. Why do I have k to the fourth? Because there's a k right here, and there's 3 more right there. 1 plus 3. When I do that, then I can write it as 1 over 2. And I have a couple options for how I can write it. I could write it as k to the negative 3, because if I do top minus bottom, I'm doing 1 minus 4. Or, because I want to make sure that I only have positive whole number exponents, that's in the directions here, I can write it as 1 over 2k to the third. And when we teach you the rule, we usually teach you to just go top minus bottom, because that tells you the power you get when your exponent's on the top of the fraction. But you can also extend that rule and think of doing bottom minus top, 4 minus 1, as long as you leave your answer on the bottom then. Skipping along to number 16. This is that distributive idea I was talking about just a second ago. 3 to the third, m squared to the third becomes m to the sixth. N cubed to the third becomes n to the ninth. So altogether we got 27, m to the sixth, n to the ninth. You don't have to worry about these 3 problems. We took off the fraction exponents this year. Let's do one more. Let's look at problem 20. So when I look at problem 20, I'm just looking for stuff that's on the top and the bottom. So I see a 2 and a 2. Then I look at my x's. I see an x to the fourth and an x to the fourth. And then the y's, I don't see necessarily how to cancel those. They aren't exactly the same. So I'll just write y to the negative 4. On the bottom, I've got a 4x and a y to the third. Ask yourself, why did I not write down y to the 0? Well, remember, y to the 0 is equal to 1. So multiplying something by 1 doesn't change anything. Second to last thing I'll do is I can take my y values. Here I've got 2 different y's. I can do top minus bottom to get negative 4 minus 3 is negative 7. And then I can move the y to the 7 to the bottom because negative exponents turn into division. So obviously there's a lot of problems I skipped. Again, just comment or shoot me a message and I can do more. Moving on to the second page, this is where we're looking at functions. Remember I showed you how to use your calculator to get a lot of these done. If you really feel like doing it by hand, you would remember that what we're talking about is y equals y-intercept times growth factor or decay factor to the x, bm to the x. So when I look at a table, I know it starts with the b, and then it goes times 2, times 2, times 2. It's growth because it's getting bigger. When I try to draw my graph, it says to label your axes because the numbers get real big. You're not going to fit them on there. And so it'd be really a good idea to count by something bigger, like maybe count by 4s, 4, 8, 12, etc. 1, 2, 3. So 0, comma 4, 1, comma 8, 2, comma 16, 3, comma 32 is already going to be 1, 2, 3, 4, 5, 6, 7, 8 boxes up. No matter how you label your boxes, by the way, it still will grow exponentially, as long as you label your boxes linearly, I should say. Write the equation of the graph. Well, I see the y-intercept is 4, and I see it goes up to 12, so that multiplied by 3. Write the equation for the table. I see that it starts with 64. That's the y-intercept. And then this is a bit trickier because I don't think it's 100% obvious what you multiply 64 by to turn it into 48. But remember, you can always find your m value by dividing two consecutive y values. I just chose the first two in the table, but I could just as easily have done 36 divided by 48. Or I could have even done 27 divided by 36. Either way, it's 3/4. You don't even need to simplify your m down. I will accept this answer. But if you want to simplify it, you could write 3/4 to the x. If you are one of those people who suffers from decimalitis, you can do 0.75. It's all correct. Sliding on down just a little bit more, I'll do 2 of these word problems and call it good. Here we got, every time Pinocchio lies, his nose grows about 20% of its size, and his nose is originally 2 inches long. So it grows longer every time, gaining 20% every time. And so I know his m, oops, let's try that again. I know the m is, well, he keeps 100% of the original and adds 20 more percent, 120%. So 120%. So if I switch that into a decimal, 1.2. If I wanted to make it a fraction, I could, but in this case, it's easier to keep it as a decimal. And originally his nose is 2 inches long, so that's the b. So the equation is y equals 2 times 1.2 raised to the x. For 20 lies, then, I just have to replace the letter x with 20. And to figure out when it'll be longer than 3 feet, that's when I would use good friend the calculator here and just type in 2 times 1.2 raised to the x, like that. And I'm going to just look at the table. So I hit second graph. And looking at the table of values here, try to answer it yourself. It looks to me like just on the third lie. Yeah, lie number 1, it's 2.4. Lie number 2, it's 2.88. So by lie number 3, it's that way. All right, last one for this video. You can always ask for more. Jiminy Cricket is 3 feet away from his house. Can't jump as far each time. His first jump is half the distance. Each jump is half the distance of that. Each jump is half the distance of that. So 3 is his original distance times 1/2 raised to the x, because each jump is half as long as the last one. If I plug in x equals 1, 3 times 1/2 is 1.5. So this matches up where x is the number of jumps and y is the distance of that that particular jump. Or actually, also, it's the same as the distance that's left over to go, because if he jumps 1.5 feet the first time, that's also the same as the distance he has remaining to go. If he jumps half of that, then there's half of the remaining distance left over. So this actually works both ways to tell you how far his most recent jump is and how far he has left to go. And so the answer to the first one would just be 3 times 1/2 to the 10th. Oh, I guess I didn't, on my last word problem, I kind of just left my answer written out as to the 20th. I'm actually going to go back and fix that. My bad. So on this previous one, I should have actually just typed this into the calculator and gotten 76.675 feet. So he's got a real big nose there. And same sort of idea, if I type in for Jiminy Cricket 3 times 1/2 raised to the 10th, he has got 0.0029297, etc. He's pretty dang close to the house. But will he ever make it? No. Uh, I'll say there's always a positive number left. If you keep getting half and half and half and half and half as close, you'll never reach the house. And this is, by the way, for those of you who care about the math history, this is a really famous situation that a guy named Zeno came up with way back in the day, Zeno's paradox. And he used kind of a tortoise and the hare situation. He used the Greek runner Achilles, who's very fast, and a tortoise. And he claimed that this means that Achilles could never catch up to a tortoise in a race because of course he'd have to get halfway to the tortoise and then halfway to the tortoise and then halfway to the tortoise, and there'd always be a certain distance left over. And so that's one of Zeno's famous paradoxes, and it's really just an exponential function. The idea that even if you get half as close, half as close, half as close, you'll never have a distance of 0. So there you go. Like I said a couple times, I only did some of the problems in the review. If you need more, let me know, and I'm happy to do them. Thanks.